Hi everyone, this screencast is specifically for my Year 11 physics class where I'm going to show you how we can do a lovely scatter chart of the data we've collected in this prac. So we have our X coordinates, which is the time, and our Y values, which are the temperature, best estimate and uncertainty. This is not the actual data from your prac, this is just some made up numbers, but it'll serve purpose. Here we go. I'm going to highlight the X values. I'm pressing the Control key on my keyboard and highlighting the Y values. Insert from the ribbon and select a scatter chart. Just go for the points at this stage. Don't worry about lines yet. We'll get to the lines in a moment. Now, that chart title needs to be improved. This is a heating curve, and particularly it was an ice-water mixture that we were working with. So there's a sensible title. The addition sign here allows me to add in some labels for the axes. For the vertical scale, that was temperature, and the units were degrees Celsius. Now on a Windows keyboard, especially one that's got a keypad on the right hand side, you can use a shortcut where you press and hold the Alt key, then 0176 is the code, release the Alt key and you get your degree symbol. That's a very handy little trick. I don't know what to do if you're not using a Windows machine. That's where the internet can help you. Now the bottom one, this was time, and that's in seconds, of course. So the axes are labeled and there are units and there's a title. That's pretty good. The next thing I want to deal with is error bars, because these data points are good, but there was an uncertainty. Now, of course, uncertainty of plus or minus 5 and plus or minus 2, well, this is just made up. But here we go. This is what we do. I'm clicking on any one of the blue dots to select the data series, and then I'm going to add error bars. So put a tick. The error bars that are added automatically are pretty awful. So I'm going to move that little, go to the little right arrow down to more options. And we're over here. Now, I could use a fixed value in this case, not the best choice, because even though the errors are all the same value in this case, not always the case. So I'm going to go to Customize and specify the values. So I get to put X positive, how much add, how much take away. They're both the same, but I specify by clicking that little icon, and these are the horizontals, yes. So I highlight where the data is there. I do the same thing for the how much to take away. And I go, thank you very much. So the horizontal error bars are now plus or minus 5. I will click on the vertical error bar, and now we're on verticals. I'll do a custom on those as well. And these ones are going to be plus minus 2 for each of them. There we are. Thank you very much. Now, don't need that anymore over there. Now, the advantage of doing it this way is that if for some reason, now the error bars in this case are all the same. In some experiments, the error bars will be different for every different data point. Just say, for instance, that the error bar for that one was 5. Do you see how that point in the middle now has its own error bar as stored there? Much more convenient to have it specified like that on the data sheet. Now the next bit is where we're going to do some, put in a line of best fit. But before we do that, I mean, we could just add in a trend line, and then we could go, oh, look at that, there's a trend line, and we could go, I want to display the equation of the line on the chart. Now, that's pretty much what you might have done back in grade 10, but that's actually a terrible job for this experiment, because look at what's going on. We've got almost horizontal here, because that's where the phase change was occurring as the ice was being heated and turning into liquid water. This is the part we're really interested in, where the liquid water is increasing in temperature as a result of absorbing heat. And then this bit at the top, that's the phase change where the water was boiling. Now, I really only want the trend line to be the part in the middle. So just by letting Excel do its automatic thing, that's actually a terrible job. I've deleted that. Now let's think a bit more carefully. That data point there at 60 is probably the first one that I need to include in my trend line, and all the way up to, I would say, that one there at 165. So from 60 to 165. So that one down to there. I'm going to just, oh, I pressed the wrong thing. I'm going to copy those values and just drop them down over there. I'm going to copy the Y values of the same and drop them beside. And just labeling these X and Y for the moment, so I've got that straight in my head. I'm going to need to do some statistics. Sorry about that, but Excel will help me. I want to know the average value of those X data points, and I want to know the average value of the Y data points. Now that average point, I want displayed on my graph. My graph's a little bit small, isn't it? Let me just make that a bit bigger so it's easier for us to see. I want that point displayed. By clicking on the graph and then going to the Design tab at the top of the page, I can add a data series. So the one that's already there, Series 1 is the blue dots. If I add a data series, I'm going to say the X value is there and the Y value is there. And say thank you. The orange dot is the, now I like that it's orange, I like that it's different because it's not a measurement, it's the average of the part that I think is going to be where our trend line goes. Now, time for a little bit of mathematics. Sorry, I know we're doing physics, but we can't avoid it. Now, here is a rough representation. The little black dots are my data points. This is my average X and my average Y, the orange one. The best fit line must go through that average point, absolutely guaranteed. And what I'd really like is for Excel to calculate a whole series of other points that I could have based on X and Y values. So the way to solve this, if I know the XY point, I need to know the gradient. You see, gradient equals y2 take y1 over x2 take x1. I need a gradient. How can I get Excel to tell me the best possible gradient that belongs to these data points? Well, thankfully, there is a way. I will make a little space down the bottom here where it says slope. And intercept. And so I remember what's going on, I'll write value and error. Now, highlight the 4 cells there. The words are just there for us humans. Excel wouldn't care about the words, but the 4 cells there need to be highlighted. Press the equals key. Excel has a beautiful command called linest, linest or linest. It's the Excel way of calculating a best fit straight line. It says, you put a bracket, it says the Y values, please. Those are the Y values. Put a comma. Then it says, I want to know the X values. That's the X values we want it to work with. Put a comma. And the next 2 things are just options. And we need both of them to be true. So you write true, true, close the brackets. Now be careful here. When I press the enter key, I want that formula to go in all 4 of those highlighted cells. I do this by pressing and holding the control and shift key on my keyboard, and now I press the enter key. Look at that, beautiful. I've got the gradient of the line. That's what I was talking about a moment ago. M is the gradient. I've also got statistically the uncertainty in that gradient. More about that in a minute. So there's the gradient of the line, and I know one of the orange point is that point. So using a little bit of grade 10 maths, if I know a point that fits on the line and I know the gradient of the line, I should be able to work out the line. And it'll be a lot better than that one that Excel threw in there automatically. this is where I come back to here. Rearranging this formula, I would multiply the x2 and the x1 together by the gradient, and then I would, instead of y2, take y1, I've thrown the y1 across the other side. I could use average x and average y as my fixed point, x1 and y1. My x and my y, well, they are variables, and the gradient, now here's the thing, the gradient could be subject to uncertainty, and 3 times the uncertainty. The little delta there means the uncertainty in the gradient. Now I'll just copy, I wrote this down and put it here before. I'll bring that up here so we can see now. Let's put that up at the top of the page. So there's a bit of maths going on behind that, but the upshot is I'm going to get Excel to tell me the best possible line to run through those points. Here I go. Start with an equals. Now the formula is gradient plus or minus uncertainty. Well, if I want the best line, I'll just take the gradient value. I'm pressing the F4 key to make that a fixed reference. Then I'm going to multiply by, I've opened a pair of brackets, X. The X here is the variable. That's the numbers 60, 75, and so on. So I'll just click on that one, no dollar signs. Subtract X average. X average is always the number 112.5. Dollar signs on that one to fix that one. Close the brackets. And then plus Y average. Again, dollar signs for Y average. That means that when X equals 60, the best fit line predicts that the Y value should be 3.333. We measured 5. We copy that down. That's the best fit line. I'm going to add that to my graph. Click the graph, go design, go select data, and go add. And I'm going to say the X values belong here, and the Y values are these. Thank you very much. Away it goes. It's put some extra data points in there. They're a bit hard to see. They're these gray dots. Now I don't really want them to be dots. I want them to be a line. So I'm going to go to the Format tab. Across here, I will choose series number 3, and then Format Selection. Over here, use the thing that looks like a bucket. We've got line options. See, there's no line. I actually want a solid line. It can be blue. Blue is fine, but I don't want it to be quite so thick. I'll make it thinner. Now, marker options, I don't want any markers. I just want the line. Now, there's my best fit trend line, just using the data points that I was interested in, and you see it goes exactly through that average point. Now, we can do even better. We can do a minimum and a maximum line of best fit. This will still go through the orange point for the average, but the gradient will be bigger by 3 times the error. Now you might wonder why I say 3 times the error. That's because when we're doing our experiments in high school, when we do our error bars, we don't use the full statistical analysis, but Excel does. So to compensate for the fact that we use slightly, not wrong, but just slightly less sophisticated statistics, we have to make that uncertainty value 3 times bigger than what it comes out as from the formula. So the formula is so useful that it's worth doing and then making this small adjustment factor of 3 times. So I'm going to use this formula again, but I'll put minus because it's a minimum gradient. So here I go. I start with brackets, value of the gradient, lock that in, minus 3 times the size of the uncertainty in the gradient, lock that one as well, close brackets, multiply by. Now, X is the number 60. I don't want that to be locked in. I want that to copy down the column. Minus X average, lock that one in, close the brackets, and then add Y average, lock that one in. Copy that down. Now I'll quickly do this one over here at the same time. So we want gradient fixed plus this time, not minus. So plus 3 times the uncertainty. Lock in the uncertainty, close the brackets. Now that's the x that doesn't get fixed. Subtract x average plus y average. Copy that one down. Now we're going to have to add the min and the max data points onto our chart. Here we go. Click the chart, go to the Design tab, select Data, add a series. X values are in blue there. Y values this time are the minimum ones. And let's add another data series while we're at it. X values are the same ones. Y values are those ones. Now I've got extra dots going on my graph over here. So let's format those. Go to series number 4, format the selection. Once again, the thing that looks like bucket. We do not want markers showing. We do want a line. Now I will reduce the size of the line, the thickness, and I might make it a dotted line. That's that one. Should be good. Now I'll go to series 5. Once again, format that. I want a solid line, reduce the thickness, make it a dotted line, and markers, I do not want markers for that. I think I did it. So there is my chart. It's got line of best fit going through the average point. It's got maximum and minimum line. It's pretty small, isn't it? If I wanted to ignore those bits of data at the front and the back, I could always format the axis. Now the lowest, I could go from 50 to about, where did I get to? I think I got to about 165, didn't I? What if I went from 50 to 170? Now, that's a more interesting looking graph, isn't it? Because I can see clearly those horizontal and error bars. The vertical ones are still pretty small. You can see the effect of that line of best fit and the greatest and least one. It tends to go through the error bars near the extrema, doesn't it? Now, that's it. Look, thank you for staying with me. This is one of my longer videos, but it's, I think, a great way of making really high quality graphs to put into your student experiments or your research investigations and things like that for your assessments. So thanks for watching, and I'll see you next time.